Hello, pre-calculus students. This is Mr. McAllen, and today we're going to be working on the properties of logarithms. These properties help us either expand or compress a set of logarithms so that we can move on to another step in solving a problem which involves logarithms. So, as an example, we have a product rule for logarithms, and that would be if you have a logarithm base b of x times y times z, that can be written up as three separate logarithms being added, all with the same base. But the key point here is that logarithms convert multiplication, you can see here this is multiplying three variables, to the addition of three logarithms. You can also just work with this if you only have two things being multiplied, but I just want to show you for the sake of argument that even if you have three things being multiplied, that this would work. Now if multiplication results in the summation of logarithms, then the second property, which would be the quotient rule, logically this would hold true that if you have a quotient of two terms, that would turn into the subtraction of two logarithms. Now, let's say, for example, that you had a combination of a quotient and a multiplication. So let's just say that you had log base b of x, y on top, and z in the bottom. Then the logarithm would be expanded into the following. You would have the log base b of x plus the log base b of y minus the log base b of z. So that's how you kind of combine both sets of rules. The last rule that we have to work on is the power rule. The power rule says that if you have a log, I'll just use just a generic base b again, of x to a power, let's say x squared, the power rule basically says that you can bring the power down in front of the logarithm. So that would mean that 2 would come down in front of log base b of x. Now to extend this to be something more generic, you could also say that log base b of x to the n power, that n would also come down in front. To prove this rule, if we use, let's say, the squared one, you could rewrite x squared as x times x. And remember what our power rule said, or our product rule said. It said that if you have the multiplication of two logs, it turns into the summation of those logs. Therefore resulting in a 2 times the log base b of x, and proving our rule of bringing that power down in front. So I'm going to box in the important rules, and you should definitely jot them down. This is the power rule. This is the quotient rule. And this is the power rule. You should definitely jot them down, and I'm going to pause the video and put an example up so we can practice with these. Okay, so I'm back, and we have 4 different types of examples. The first example is expressing a single logarithm as a sum or difference of logs. So you can see here on the inside of logarithm I have 2 times x times y cubed. So what I'm first going to do is I'm going to break that up into 3 logarithms. Log base 3 of 2 plus log base 3 of x plus log base 3 of y cubed. And now I'm going to just change the last logarithm using the power rule and bring that power down in front. So log base 3 of 2 plus log base 3 of x plus log base 3 of y with the 3 out in front. And the next one, I'm going to express this as a sum or difference of natural logs because the logarithm is a natural log type. So I'm going to write natural log of x squared minus natural log of y cubed. And the next thing I'm going to do is I'm going to bring the 2 down in front using the product rule. And don't forget to put the 3 in front. So that would be my answer to this one. In the next one, they're asking me to write 3 logarithms as a compression as far as 1 logarithm. Okay? So I'm going to, when I see the subtraction, I'm going to convert that to x over y, but then I'm adding this other logarithm, and I'm going to put the z in the numerator. So that was pretty easy. And then in the very last one, where I have a 2 coefficient and a 3 coefficient, the first thing I'm going to do is move the squared, the 2 up to the top is squared, add to it natural log of y being cubed, and then we're going to put it together as a product of those 2. Hopefully these couple of examples have helped you understand how to use the properties of logarithms to solve some of the problems we'll do in class tomorrow. Look forward to hearing your comments. Have a good day.